All right, here we go. So if this was a normal equation, what would you do first to solve? Distribute, right? So this will give us 5y squared plus 7y less than 3y plus 12. All right. Now what would you do? Move everything over so you can set it equal to 0, right? So I'm going to subtract 3y. Subtract 3y. I'm also going to go ahead and subtract 12 over there, but I can't combine it with anything. This is going to be that minus 12. So that will all go away. And I now have 0. I did not have to flip the inequality sign because all I did was subtract. I did not multiply by a negative. So now I have 5y squared plus 4y minus 12. How do we solve quadratics? You can do the factoring or you can use the formula. We can try factoring. It might be quicker. I'm not 100% sure. Remember, it's A times C. So this is A, B, C. So what's 5 times negative 12? Negative 60. And it has to add to 4. So 6 and 10. But it's going to be, yes, it's going to be a negative 6 and a positive 10. So then I get y minus 6, y plus 10. But because the leading term is not a 1, what did I have to do extra? Divide by the a, which in this case is 5. There you go. If I can't reduce the fraction, what do? Good. Take the denominator, move them to the front. So this now gives me 5y minus 6. And 10 divided by 5 is 2. So I get y plus 2 less than 0. All right. Just like before, I would set each one equal to 0. This time, I just set each one less than 0, right? And then solve them out. So I get 5y minus 6 less than 0. And I get y plus 2 less than 0. How would I solve the first one? Plus 6. So I get 5y less than 6. Then what? Divide by 5. So I get y less than 6/5. Come over here. How do I solve this one? So I'm going to do y less than negative 2. If you're having a hard time seeing what the answers are going to be, you come over here at the number line. You have a negative 2 here, and you have a 6/5 here. Both of them are going to be open circles because there's no line underneath them, and both of them are going to shade in this direction. So if my memory serves me correctly, we should just be able to say it's just less than 6/5. But before I tell you wrong, let me verify this. Interesting. Let's look at this. We need to use some test points to see if it's possible or not. So we need to know when this guy right here is less than 0. All right. So I'm going to utilize this guy. And I just need a number left of negative 2. Negative 1, right? Wait, no, sorry, left. Negative 3, yes. So if I plug in negative 3 into this, I get negative 3 squared, which is 9. 9 times 5 is 45. So that's going to be 45 minus 12 minus 12. So that's going to be a positive result. Is a positive number less than 0. So that means that this part is not part of the answer. So it's a little bit different. Yeah, because it's a quadratic and not a linear. Yes, so you're just going to pick these are basically what we call our test numbers. Sorry, our boundary numbers. And then we're going to pick test numbers between our boundary numbers to see what actually works. So a good test number between negative 2 and 6/5 would be 0. 0 would be good. So that all zeroes out and I get negative 12. Is negative 12 less than 0? Yes, so that works. try number to the right of 6/5. 2, good. So 2 squared is 4. 4 times 5 is 20. Then we get plus 8 minus 12. What's that? 12 minus 12, which is 0. Is 0 less than 0? No. So this part won't work either. So therefore, your answer here. You're right. You're right. For some reason, I did 20 minus 8, got 12 minus 12. Okay, yeah. But still, 28 minus 12 is a positive number, still not less than 0. Yes. Whew. Okay. Going too fast. All right, here we go. So then our answers are going to be -2 6/5, and we put parentheses around that because of the less than no line underneath it. All right. So when dealing with a quadratic and inequalities, you're going to get these boundary numbers, and then you go find some test numbers between your boundary numbers to determine what's actually accurate there. It's kind of different from those linear ones where we could just look at the inequality sign. Questions on that? It's a little bit different than our norm. All right, let's work on the next one. Give you a chance to write that down. I know. Every period. I just feel like it's somebody's phone right there. All right, ready? Okay. So this is a 4-term polynomial. However, when we are trying to solve these, what's our number one question? Is there a greatest common factor? So what's the greatest common factor here? I actually see a negative. So that one, I don't like negatives. But I think a 4 goes into all those too. So that's going to be -4x as my greatest common factor. So when I do that, I'm left with what? Ooh, minus x squared. It's 16, ain't it? All right, so then we're in a little bit of pickle. Typically in a 4-term polynomial, we try to factor by grouping, but just looking at this, I can tell you that's not going to work out for us. So then this is where we use our skills that we've learned up to this point when solving polynomial functions of greater than x squared. And you need to find some possible zeros so that we can use synthetic division to go the rest of the way. Yes. Yeah. Which is a great review for things that you're going to have to do on the test. So to find possible zeros, remember, I'm going to take, do what? You're going to take, man, where's my brain? Right, I know. It's the factors of the last term. So what's all my factors of 20? So plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, and plus or minus 20. All divided by the leading new term. So we kind of saved ourselves some work there by reducing our numbers, which is just a what? Just a plus or minus 1. And then we're left with all of those numbers. All right. So guess the number. Okay. I hope you're right. So the x cubed here is now a 1. The x squared is a -1. The x is a -16. And my constant is a -20. So we work the work. We get 1, 4, 3, 12, -4. I do apologize for going so fast, but I know we're going to get caught. That did not work, Matthew. Okay, try -4. I hope you're right. -4, -5, 20, 4, -20. Oh, that was close. It was close. Okay. right? Because no, negative 16. Regardless, it still didn't work. Negative 2. So 1, negative 2, negative 3. That's going to be what? 6, negative 10, 20, 0. It's negative 2. And probably 5 as well. All right, but regardless, this right here then turns into x squared minus 3x minus 10. We do our t chart here. What two numbers multiply to negative 10 but add to negative 3? Good. So that gives us negative 5 and 2. That gives us x minus 5, x plus 2. Good thing is there's no other than there's nothing greater than 1 on the leading term, so I don't got to worry about dividing. So I'm going to come back, and this guy ends up being negative 4x, because that was my original GCF, x minus 5, x plus 2, all greater than or equal to 0. So let's find our boundary numbers by basically setting them all greater than or equal to 0. So negative 4x greater than or equal to 0 would be what? 0, but because I'm dividing by negative, I would flip the inequality sign. So now it becomes x less than 0, but we're really just looking for boundary numbers, so we don't even know if it'll go that direction. So each one of these are factors. Now I'm going to set each factor greater than or equal to 0. So then this is x minus 5 greater than or equal to 0, which is x greater than or equal to 5. This is x plus 2 greater than or equal to 0. So this is x greater than or equal to negative 2. So those are all your test numbers. So you have a negative 2, a 0, and a 5. All right, so choose a number to the left of negative 2. Negative 3. All righty. Ooh, it's gonna be good. It's gonna be good. You can plug into either one. All right, well, I know that's going to be a positive 12. And then that's going to be negative 27 minus 9, 1632 plus 48 minus 20. What kind of number would that be? That's going to be, was that negative 36? Negative 30. That's going to be a positive number times a positive number. That's going to be positive. Is a positive number greater than or equal to 0? Yes, so that works. Then we choose a number between negative 2 and 0. Negative 1. This might be a little bit easier. This is going to be 4. And then that's going to be a negative 1 minus 1 plus 16 minus 20. That's going to end up being a negative times a positive, which is negative. Negative is not greater than 0, so that part does not work. Choose a number between 0 and 5. 1. So you get negative 4. I need more room in my slides. Then that's going to be 1 minus 1 minus 16 minus 20. Obviously, that's going to be a negative times a negative, which is a positive, which is greater than or equal to 0. So that does work. Okay. And then choose a number greater than 5. 6. Woo, okay. So it's going to be negative 24. That's a 20. All right, I wrote that. It is. What was our number? 6? 6 cubed is 36 times 6, which is 216. I raised it to the third power, yeah. So yeah, negative 4 times 6 is negative 24. I'm plugging it into this number here, yeah. I figured it'd be easier than that to multiply by 80 in my head. 6 squared is 36. That's minus 36. 16 times 6 would be. What's the easier one? That's what I'm plugging it in. Yeah, I'm plugging in this one. That's what I've been doing. You are so true. I don't know why I did not do that. Oh, that would have been so much easier numbers. Yes, you could have used this one that we did all the work on earlier. Well, little lessons learned. All right, I'm already committed. 6 times 16, that's gonna be 60, 36, 106. 60 plus 36 is 90, not 100. All right, cool. Minus 20, that's going to be 116. That's going to be a positive negative. That's going to be a negative. Is a negative greater than or equal to 0? No. So our answers here are going to be okay. Okay, so this is going to be negative infinity to negative 2 bracket, because now it does have a line underneath it, union bracket 0 comma 5 bracket. Oh my gosh, it's like a delay when I try to write. Yep, and that's it. I like how you say that though. Like, oh, that's it. All right, perfect. Yep. Yeah, that's good. All right. Objective 2, we're now going to do the same thing by solving rational inequalities. All righty. Give you a chance to write those down. Mm-hmm. This is the easy stuff. What are you going to do? Yeah, I was waiting for you to finish it. I think that it has to be a phone. But it's every class period, so it makes me think either A, it's her phone, or B, she has one of those little phone thingies hanging on that wall. So all the phones that are going off, that's my assumptions. I really don't know. I just know her desk is right there. So, oh. All right, we ready? All right. To solve rational functions, we solve it basically with like a fraction where we just cross multiply. But what's fun about this is when you take this whole thing times 0, it just goes away. So you're really just left with negative x squared less than or equal to 0. How would I solve it? Because when you just cross multiply there, that just becomes 0. And then 1 times this is just that. So I solve rational equations and inequalities. Yep. So that would good. So that would have to divide by negative or multiply by negative. But when I do that, this gives me now a greater than or equal to 0. Now what would I do? Square root it, which is still just going to be 0. Bless you. So on part A, we just see that the answer is going to be, let's see if I'm going 0. So that's going to be 0, 0 to infinity. Oh, but what should the Man, I got that all backwards there. What should the 0 be? Gosh, go away. Delay. I do not. Need y'all to be here so I don't have to use this technology. All right, so I do the same concept here, and I get to this point here, negative x squared less than 0. We know that that will flip, and I'll be left with x greater than 0. So same answer. The only difference is now it is 0 with a parentheses. Then we do the same thing, and now we get negative x is greater than 0. So we know that that's going to flip. So that's going to now give me x less than or equal to 0. So now I get that negative infinity to 0 with a bracket. Pencil. Let's see what color this ends up being. So this is going to be negative x squared greater than 0. So we know that's going to turn into x less than 0. This has been a bracket, guys. Why didn't y'all say something? Oh, I did put a bracket. Sorry. My bad. I'm so lost. All right, so negative infinity, 0 parentheses. I didn't say nothing because it wasn't wrong. There you go. All right, ready? The next one. Okay. Now it's not, we have to actually do some math. Ah, tartar sauce. That's why we say it out loud. I like that. Are we ready? I like that color gray. That was kind of cool. You didn't like the color gray? I don't know. We're gonna do this problem in gray, and we're gonna judge, see if we like it or not. We ready? Is it a silver? It looks like pencil. Huh? Nope. We're going to solve it by getting rid of the fractions by cross multiplying. So that becomes 3 minus x greater than or equal to 4x plus 8. Huh? Say one more time. The utopia animal. Oh, the sloth at the DMV. I'm only doing that because I can only write as fast as the computer will allow me to. Yes, ma'am. It does. Yes. This has to go to the left. This has to go to the right. That's a very good question. Well, then that would be the same answer if you flipped the inequality sign. Yes, sorry. This to the numerator is on the left. This to the denominator is on the bottom, or on the right, sorry. That's right. All right, so what would you do to solve it? Good, I'm gonna add x. And just to do this all at once, I'm gonna go ahead and subtract 8 as well. You don't have to. I know I'm short on time. So this is gonna be -5 greater than or equal to 5x. That would go away. Divide by 5, that's correct, yes? Yes. All right, so then how would you write that out? If it helps, flip your answer. So it looks like this. If it makes it, oh my goodness, what? I don't know what that was. So what's the answer? That's good. We good? Awesome sauce. I cross multiplied. I got my x's to one side, got my constant to one side. I did it all at once due to time. And then I went ahead and divided the number that the coefficient that was next to the x. So I'm isolating my variable. What do you think about gray? It's okay. Yeah. It was new. I don't have purple. That's our highlighters. Very nice. All right. Again, now we have basically something other than just a whole number. Oh, I need to write it down. I wish. because you'll end up with 4x. I don't know. In my head, I have an idea. But let's work it out like we know it. And then I wonder if it'll work out the same way. Gotcha. This to the left. So that's going to be 4x minus 3. And then greater than or equal to. That's what I said. I don't know why I wrote a 3. 12. Good. I don't know. And then that's x minus 3. Nope, that idea didn't work. I take it back. Okay. Huh? Okay, I'm going to subtract x. And I'm going to add 12. So that's going to give me 3x greater than or equal to 9. And then that's going to be x greater than or equal to 3. Oh my, come on now. All right, and then therefore it's going that way. So that should be 3 with a bracket to infinity. All right. Has anyone gotten to the homework? Did they actually see word problems on 3-7? All right, cool. All right, last question then. All right, so objective 3, we're going to solve application involving polynomial and rational inequalities. Suppose that a basketball player jumps straight up for a rebound. If the initial speed leaving the ground is 16 feet per second, we're going to write a function of the player's vertical position s of t in feet at time t seconds after leaving the ground. Well, one, I know in the past, when these type of problems are given to you, they always give you what the equation is for the velocity or acceleration or displacement. Let me go find it, because other than that, you have to memorize it. But every problem I've ever seen, they always give it to you. Okay. So here you go. So here's the equation. Am I still on purple? I just hit pen. Okay. So it is S of t. And you might not have seen this in physics, but it's then -1/2 g of t squared plus the initial velocity times t plus the initial distance. And then a couple things you need to know about g, just so you know, with gravity. S0, so that's your just. It's usually given to you. I mean, every problem I've ever seen is given to you. If it doesn't, just go back to the notes. I didn't give a question like this on the test. But everything in my head, I've always been given that equation. But this is a physics thing. But gravity is equal to two different things: 32 feet per second squared. And yes, that's the one we usually use. They just round it to 9.8 meters per second squared. That's a 9.8 for the people watching the video. I don't feel like erasing. All right, so once the formula is given to you, then the life gets a lot easier, because all you got to do is make sure you're in the right units, and then you just plug in. Yes, ma'am. Now that's 32. Yes, that's what we're just asking. There. SO for initial distance. You have initial velocity and they either use distance or displacement or something. I don't know what the initial height. I think that's what it is. Huh? Oh no, it didn't catch the rest of my parentheses. feet per second squared and 9.8 meters second squared. So depending if your units are in feet or meters will depend on which number you use. Yes, S0 for initial height. No, it's not. I don't know. It looks the same. All right, ready? Okay, so in part A, I'm literally just going to plug in what I know and simplify. So I have S of t equals -1/2. The gravity, am I going to use 32 or 9.8? And how do you know? Is G going to be 32 or 9.8 and why? Very good. Since my unit is in feet, I would use 32 times my time, which I don't know. So that's just going to be t squared, plus my initial velocity. So what's the initial speed? Speed's the same thing as velocity. 16. So it's going to be plus 16, right? If you're leaving the ground with that function. Some of these things you got to watch out too. If you're like coming towards the ground, you're like negative, I think, or something like that. Whiting would know better. And then if we're leaving the ground, that would be 0. All right, so when we reduce that, that'd give us -16t squared plus 16t. All right. Part B says find the times after. Yes. All right. And part B says find the times after leaving the ground when the player will be at a height of more than 3 feet in the air. So if you're trying to find the times at which you leave the ground where your height is 3 feet, S is basically your height. So this would just be set equal to 3. Yes, it would. You are correct. I didn't even see that word. Look at you. So this needs to be greater than, or yeah, it'll be a less than in this situation. So that side's greater than, but not a greater than or equal to, since it just said more than only. And after that, I'm just going to solve it like normal. I'm actually going to move all this over because I don't like dealing with negatives. So that's going to be 16t squared minus 16t plus 3 less than 0. All I did was move everything on the right to the left so I don't have to deal with negatives. And then the real fun begins. Most likely the quadratic formula is probably going to be your best bet because what's that? 3 times 16 is 48. I don't know two numbers that multiply to 48 yet. 2 and 24. Yeah, but that doesn't add to 16. So 3 goes into 48. How many times? 1, 6. That's 16, but 4 and -4 and -12. Yes. Yeah. Okay. Yeah. Okay. So yes. So this is what was it? 48 is what A times C is. -16. So that's going to be 4 and 12. Brain fart over here. So that's going to be x minus 4, x minus 12, because that right there, 16 adds up. Okay, perfect. And then I divide by the 16 because I have to divide by A. And so it doesn't go into it evenly, but it does reduce down to 1/4. And 4 goes into 12, 3/4. And then I just bring this to the front. So I really have 4x minus 1, 4x minus 3. Set those equal to 0. I know we're short on time. So it's going to be x equals 1/4. This is going to be x equals 3/4. They're going to ask me, but this is a 4 on the bottom right here that I keep tracing over. So therefore, find the times at which is 3 feet in the air. It would be 1/4 seconds and 3/4 seconds. If you want to write those as decimals, that's completely fine as well. All right. Yes. Oh, because it said find the times that they're leaving the ground where, oh, and here's the thing, it's a greater than, it's not equal to. So those are our test points, where here's 1/4 and 3/4, because we want to know at what values is it greater than 3 feet. So if you choose a number like 0, plug that in. 3 is less than 0. Is that true? Oh, sorry. Here's my boundary numbers. So I got to find test numbers. So I chose 0. You plug 0 in there, you get 3 less than 0. Is that true? No. So this is not going to be part of the answer. Choose something that's between 1/4 and 3/4. 1/2. Yeah. 1/2 squared is 1/4. 1/4 times 16 is 4. Minus 8 is -4. Plus 3 is -1. Is -1 less than 0? Yes, so that works. Choose something greater than 3/4. 1. 16 minus 16 goes away. Then you just got 3 less than 0, which is not true as well. So really, in this question, since we're looking for more than and not equal to, it will be, we got a, yeah, so 1/4 to 3/4. That would be your interval of time. All right, so let's look at the review really quickly, because I'm sure we're going to get called out here shortly. And if I have time at some point today, I will kind of go through all these. Yeah. I don't know. Ready? Okay. Huh? I do news share. No, I don't want that. What's that button do? Oh, I want a whiteboard. That's what I want. Share the whiteboard. Got it. Okay. Do you want to just go in order, or how y'all want me to do this? Okay. So the first question, you have 5x equals -2x squared. Where are you? No, I didn't. I'm on this. That is the first one. I just don't know. Why did this move? Okay. Let me put a square here. Okay. Look, I just made it and I look for some questions. All right, guys. Look, technically, I don't even have to give a review. I'm trying to be kind here. All right. All right, if we look at part A here, if I want you to put it in vertex form, this is where that completing the square comes into play that we learned in 3.1. So what we're going to do is actually divide everything by -2, because you have to have the leading term has to be a 1. So that becomes f of x over -2. Come on. I need things to go with me. Wow. Eventually, if I can ever get there. How do you delete this one? I know what it. It's whatever. X minus 2x where? Ah, square. All right, -3. Thank you. Thank you. All right, and then this is, yes, we're going to add a blank and subtract a blank so we don't change the value of the expression. Yes, ma'am. So that'd be -2x plus a blank. This is going to be fun for y'all to listen to later. Yep. So now do y'all remember how you get the blank? b divided by 2 squared. That will not be given to you, so make sure you remember that. So that's 1 divided by 2. Wait, no, it's 2 divided by 2, which is 1, 1 squared, which is 1. Very good. This guy right here factors into this nice binomial that's squared. You write whatever that letter is. And then how do I get the missing number there? Just b divided by 2. So negative 2 divided by 2 is negative 1. And then I can do the math here. What's negative 1 minus 3? Again, all of this was equal to this right here. So then I'm going to take this whole thing, multiply it by negative 2. Boom, boom, boom. I then get 5. No, that's an f. So f of x equals negative 2. Do not distribute that negative 2 into that binomial. You can't because of the square. So we're just going to write the negative 2 in front of that binomial. But we will do negative 2 times negative 4, which gives us plus 8. Sorry, guys.